Our first speaker, I'm going to introduce him while he gets set up. Our first speaker is Xiang Li. I hope I'm pronouncing it correctly. He's a staff scientist at the Atomic, Molecular, and Optical Sciences Department and at the LCLS. He studies ultrafast processes in atoms and molecules with charged particle spectroscopy at XFELS. He also is involved in the design and operation of experimental end stations at the AMO beamline at the LS, as well as the software development for AMO experiments performed at free-electron laser facilities. All right, the floor is yours.
Thanks for the intro. Hi, everyone. My talk is on our data analysis software called the Dream Endstation at the LCLS. So Yana has presented the data, how the data flows at the LCLS. I'm going to zoom into how the data flows for specific endstation. The Dream is a direction microscope that allows us to look into the ultra-fast atomic and molecular processes by detecting electrons and ions in coincidence. It is one of the few endstations that can make full use of the high repetition rate of the LSSDA. This slide shows how the data flows during a typical Dream experiment. And the software is shown by the blue boxes. Our main detector is the high-speed digitizers. In addition, we also have 1D and 2D cameras, also FEL data, other data including ethics variables. The software can do real-time analysis as the data is being taken by the data acquisition system, and it can also do live mode analysis and pre-processing as the data is written to the disk or saved after it is saved to the disk. And the pre-processed data is then saved as small as 5 files, which are provided to the users for the post-processing. Our framework has the following features. It's designed not only for the Dream endstation, but also for other endstations as well. It's capable of running both online and offline. Analysis is configurable with human report files. For the online, the analysis driven by the plots requested by the users, and the offline by the content of the small file files. Here is the structure of the software. So three main parts: configuration, algorithms, detail, and the configuration. We have instrument-specific configurations for each instrument. Detector settings, algorithm settings, and the settings for the online and offline analysis. Similarly, for algorithm, we also have instrument-specific algorithms. Also, common algorithms which can be used by all endstations, such as deep learning. The util is responsible for initialization of detector and the algorithm stages, and it's also responsible for event processing, communication, and accumulation, data accumulation. So once the software is started, first look at the configuration, deciding whether it should run online or offline. For online, it will look at the plots requested by the user. For offline, we'll look at the data variables. Depending on the requests, it will initialize the detector and the algorithm instances. After the initialization, it will look through different events. And for each event, there can be multiple detectors. For each detector, the software will go through different algorithms to produce the pre-processed data. And then the pre-processed data is then communicated to the master node for accumulation. And then the data got plotted for the online analysis or saved to the HFIL file for the offline analysis. This slide shows some of the plots we had 2 weeks ago during the Dream Early Science experiment. Just made our first release and find it in the in this GitHub page. Thank you.